Bismillahirrahmanirrahim. Assalamu alaikum dear viewers, I am Dr. Noshin Afshan and you are watching Dr. Noshin Afshan YouTube. I hope that all of you would be fine and I am thankful to you for watching this video. To watch more videos, please subscribe my channel and press bell icon. So our today's lecture is about 2 substitution of 3 substituted indoles, in which we will study the electrophilic attack first of all at alpha position and then at beta position, and then the shifting of the attacking electrophile from beta position to alpha position, and that is called as 2 substitution of 3 substituted indoles. So let's see that here if we give the numbering system, nitrogen is given number 1, this is position number 2 and this is number 3. Alternatively, it is called as alpha position and number 3 is called as beta position. So we mean that in the case of alpha attack, it would go directly if electrophile attacks at indole. If in the case of this species, this electrophile attacks at alpha carbon or position number 2, then we may get this one. What would happen? This bond would be shifted to electrophile and then a positive charge would be generated at this position, at this carbon. And here there is already one hydrogen present over here, this one, and this electrophile is shown here. Here the nitrogen is attached with hydrogen. So now what would happen that this hydrogen this bond would be shifted along this position and we will get our final product. Here it is electrophile and here a double bond is being generated. This is hydrogen. So this is our final product in the case of electrophilic attack at 2 position. We say it the 2 substituted indole. Okay, and this step where proton gets eliminated, this is irreversible. This step is irreversible step where we get the 2 substituted indoles. 2 substituted indoles mean the 2 substituted indole, 2 electrophilic substituted indole. Yes, this is 2 electrophilic substituted indole because here the electrophile attacks at 2 position. Then if electrophile attacks at 3 position, then what would happen? Here this is an alkyl group R, this is electrophile and here it is positive charge. Now this positive charge which would take assistance from nitrogen lone pair, it would get over here and it would form a resonating structure like this. Here there would be double bond and one positive charge on nitrogen. So now from this position, as you know that here there is one hydrogen and this electrophile would shift from this 3 position to this position number 2. or from both of these positions. Both of these positions would lead toward this one. What would happen? This is the simple case. Here, if you consider from this electrophile would be shifted to this, and this would be shifted to nitrogen. And here, let's raise this arrowhead, then this electrophile would simply shift to this position. So in both of these cases, we will get a compound like this. Here there would be only one alkyl group because electrophile has shifted to this position, and there is also already one hydrogen over here. This hydrogen, and here is electrophile. As this electrophile has shifted to this position, the second position, so here a positive charge would be generated. So if you look back to this structure where the electrophile has attacked at alpha position, this was the intermediate for alpha attack. This is also same like this one. So from this or this position to this, we call it 3 to 2 migration. That means electrophile has migrated from position number 3 to position number 2. 3 to 2 migration of electrophile. So this migration is shown by this arrowhead. That means 3 to 2 migration of electrophile, and then from this we will get this step, this product, and similarly from this we will get this product. So at first step where electrophile attacks at beta position, this is sometimes reversible step, but when it is migrated to 2 position, then it is also irreversible. Same like this, as this is irreversible, but this step is sometimes reversible. So in this case, this shows the 3 to 2 migration of electrophile to get the electrophilic substituted indoles at electrophile at set 2 position. So these are the electrophilically substituted indoles where electrophile is attached at 2 position. So next we see the reduction of the indoles employing lithium aluminium hydride. Here it is reactions of indoles where we take a substituted indole, that is 3-acyl indole. Here 3-acyl group has been attached. That is C double bond O, and here it is R. So when it reacts with lithium aluminium hydride, as you know that this reagent acts as a strong or acts as a reducing agent. What does actually happen? This lithium aluminium hydride gets ionized into this one, lithium hydride, as a neutral species. Sorry, this is lithium aluminium hydride, LiAli and H4. This eliminates as lithium cation plus aluminium hydride AlH3 plus 1 hydride. So this species further becomes like this. It further ionizes into AlH2 positive plus H negative. So here this hydride actually attacks at this position, and here this aluminium AlH2 plus, it becomes shifted to oxygen. So here, as this hydride has attacked on this position, so this hydride is here, and this oxygen in the form of O negative becomes here. Then this anion or this negative charge on oxygen would attack at this species, AlH2 positive. And our resultant intermediate would look like this. Here O, AlH2. It would be in this form. Then one more hydrogen anion would attack on this hydrogen. This would be shifted to this position. Okay, as there is one double bond also. So here there is one double bond and also a double bond here. So when this bond would be shifted to this position, this would be shifted to this position, and this species would be eliminated. And we will get here a nitrogen has a double bond over here at this position, then a double bond over here, and then Ra, Cr, and there is understood that there is one hydrogen over here, or you may also show it like this. Then in the next step, this hydride would attack at this position. This double bond would be shifted to this, and here there was a proton over here, and this nitrogen would attack on this proton. So our resultant product would be here. Nitrogen is attached with one hydrogen, so now you see that here there would be a double bond over at this position, and then C, here it would be R group, this R, and here there would be two hydrogens. So you may show them like this. Here it is understood that there are two hydrogens. That means like this. Here there is understood that it is CH2. So this is our final product, and it is called as 3-alkyl indole. So because this alkyl group is attached at 3 position, so we call it as 3-alkyl indole. So thank you very much for watching the video. Please subscribe my channel and press bell icon. Allah Hafiz.